So you have the guided note sheets for this section. It gives you all the examples and things we're going to cover today. Okay, that way you don't have to write them down. In addition to that, we'll go through this and then review for the quiz. Okay? So we're still talking with slope-intercept form and slope. What I want you to do first is those top two problems, which are these two. Just see what you remember about this. I just want you to find the slope between these 2 points, and then we'll check it. Okay, find the slope. These two problems. Find the slope between those 2 points and the slope between the next two. They're on your sheet there. So I'll give you a couple minutes to do that. So hopefully you remembered the slope formula. Remember the slope variable is m. We take the second y-coordinate minus the first y-coordinate divided by the second x-coordinate minus the first x-coordinate. Doesn't matter which one you label. Okay, if I just label this my first x and my first y, my second x and my second y, just plug those in the formula. So I could take something like -5 minus -5 divided by 3 minus -8. Remember when you're simplifying this, what's that double negative become? Yeah, when you have a minus and negative, that's like a plus. So -5 plus 5 is 0. Same thing down here becomes a plus. 3 plus 8 is 11. And anything divided, or 0 divided by anything is 0. So the slope of that top one is 0. Which means what type of line is this? Is it vertical or horizontal? If its slope is 0. Horizontal. Remember the roller coasters, it's zero fun, or it takes zero effort to walk across something flat. It's impossible to go up something vertical. It's undefined. Yeah. Which makes sense, because if you were to think about if you were to graph these 2 points, if you were going to go to -8 and then -5 and then 3 -5 and draw a line between them, it'd be a flat line through the y-coordinate -5, right? Yeah. So then the second one, you're doing the same thing. Again, doesn't matter which one you call it first and second. Let's just do it in the order they are. So I would take -2 minus 3 divided by 6 minus -1. -2 minus 3, -5. Double negative down there becomes a plus. I get -5/7. How many of us got both those? Handful? Good. Okay. What type of line is this? Is it uphill from left to right or downhill from left to right? It's downhill because it's a negative slope. Remember, negative slopes downhill from left to right. You could either go down 5 and to the right 7, or you could go up 5 and to the left 7. Okay. So you remember how to do slope here, where this is called slope formula again. Remember, slope variable is m. Okay. So first question on there, how do you determine slope? There's 2 ways. One of them we just did. What's that called? Slope form, right? Your slope formula, slope formula, and rise over run if you have a graph. They're the same thing, right? So you can have slope formula, which is y2 minus y1 over x2 minus x1 we just used. That's one way you can find slope. The other way is if you have a graph, you do how much you go up or down divided by how much you go left or right. We call that rise over run. Okay. Good. Okay. All right, next question. There's 4 different types of slopes. We just briefly mentioned them. What's one? Yeah, Chase.
Positive.
Positive, so uphill, positive slope. What's another one? Negative slope, downhill, positive, negative. 2 others.
Undefined.
0 and undefined. Good. So you have 4 types of slope. You have a positive slope, a negative slope, a slope of 0, okay, which is a flat line or horizontal line, and undefined, which is a vertical line. Those are the only 4 cases we have in straight lines or linear lines. Right. They have to be one of those 4 things. Next, we want to find rate of change. Remember, rate of change and slope are basically synonyms. They mean the same thing. Okay? If something changes at a constant rate, we can use slope to find that out. So here it says these tickets, $48 for 4 people and $78 for 10 people, find the rate of change. We can still use the slope here and do the same thing. Okay? Let's just say the y-axis is my dollars and the x-axis, is my number of people. Okay? The dollars depends on the number of people. Y-axis is the dependent variable. So if I have 4 people cost $48 and 10 people cost $78. My x-axis is my number of people. My y-axis is my dollars. So there's my 2 points that I can find the slope between. That's the same thing as rate of change. Okay, if I call that the first x, the first y, the second x, the second y, plug those into slope formula. 78 minus 48 divided by 10 minus 4. That's 30 divided by 6. So my slope simplifies to 5, because 30 divided by 6 is 5. Okay, yeah. So my slope is 5, and my rate of change is 5. That means the tickets are changing by $5 every person, right? So if for example, if I had 5 people, it would have been $53, 5 more than that. If I would have had 6 people, it would have been $58, 7 people, so on. Eventually I get to 10 people, it's $78. 11 people would be $83. It's going by 5 at a constant rate. So my rate of change is $5 here. Okay, so slope and rate of change are the same thing. Okay, so that last question says, what's the difference between rate of change and slope? Okay, you can find them the same way. Okay, for right now, we're going to call them the same thing. Okay, you can find them the same way. Okay, next we had, again, what we're going to continue working with today, slope-intercept form, y equals mx plus b. Okay, and our two important variables, the b is the y-intercept, where it crosses the y-axis. I don't think this one's on your sheet here. Okay, and the m is the slope. Those are the two things we need to write something in slope-intercept form. And we only need two things, slope, y-intercept. We get those two things, we can write it in slope-intercept form. Okay, so for example here, these are on your sheet. I want you to go through and tell me the slope and the y-intercept of these 4 equations. Just tell me the slope, so m equals this, and the y-intercept of this, b equals this, of these 4 equations. See what you can do with that. I'll give you a couple minutes to try that. Okay, so hopefully on this first one, what number is the slope here? 3. The slope is positive 3, so it would be a positive uphill slope. You'd be going up 3 to the right 1, up 3 to the right 1. What's the y-intercept? -7, right? We treat that minus as a negative. We would start at -7 on the y-axis, and we'd go up 3 over 1, up 3 over 1. Okay. Number 2, what's the slope? Good, -2/3 is the slope. The y-intercept, good, is +6, so I'd start at the y-axis at +6. I'd be going down 2 and to the right 3, or up 2 and to the left 3. They're both downhill. Okay, very good. Now, there's one tweak you have to do to number 3. What is that? Yeah, Tyler?
Bring over the 2.
Yeah, you have to get rid of that 2 so you can get the y by itself. So you look at what the 2 is doing to the y. It's multiplying times y. So you need to undo that multiplication. You need to divide by 2. Because when you divide that by 2, 2 divided by 2 is just going to become 1y, which is what you want. But what you do to one side of the equal sign, you have to do to everything on the other side. So that means I need to divide this by 2, and I need to divide this by 2. Okay. So now it's in slope-intercept form. I'll rewrite it right over here. Y equals x over 2 minus 3 over 2. But the slope's the number in front of the x. Well, what number is in front of this x? How many x's do we have here that we don't write? 1. Okay. So that's like a 1/2 times the x, or 1x divided by 2. So the slope here is 1/2. That's the number in front of the x. I'd be going up 1 and to the right 2. Up 1 and to the right 2. Okay. The number in front of the x being multiplied to the x is the slope. What about the y-intercept? It's the number without the variable. Y-intercept here happens to be a fraction, -3/2. Okay. Or that also simplifies to 1 1/2 if you want to make it a mixed number, a decimal. It's 1 1/2. Now I won't ask you to plot these. I won't make you go to a graph and plot like 1 1/2 and then go up. The ones we plot or the ones we graph will always be integer numbers. Okay. But it's possible to have one that doesn't go through the y-axis right at a point or right at an integer, right? So slope here is 1/2. Y-intercept is -3/2. Same thing down here. Okay, and let me make some space up here so I can write this one up here because I'm running out of room. Okay. That 4y minus 2 equals 3x. Very important that before you ever do anything, graphing or identifying a slope in the y-intercept, you have to get it slope-intercept form. You have to get y by itself. So I need to solve this equation for y, get it by itself. What am I going to move over first, the -2 or the multiplication by 4? What am I going to get rid of first? Now remember, the thing closest to the y we leave till the end. Okay, we undo in reverse order of PEMDAS. Right? So we undo addition and subtraction first, then we undo multiplication and division. So I need to move that minus 2 over first. So to do that, I'm going to add 2 to both sides. That goes away, leaves me with 4y equals 3x plus 2. Now I can undo that multiplication by 4. To undo multiplication by 4, I'll divide by 4. But whatever I do to one side of the equal sign, I have to do to everything on the other. So that leaves me with y on the left side equals 3/4 x plus 2 over 4 simplifies to, now this is 2 over 2 divided by 4, not 4 divided by 2, 1/2. So there is my slope-intercept form of that equation. Now it's much easier to graph, much easier to tell what the slope is. Okay. What's the slope in this equation? 3/4. Good, the number in front of the x. So in number 4, m equals 3/4. In b, the y-intercept equals 1/2. Okay. So you'd be going at the y-axis, you'd be at 1/2, then you'd go up 3 over 4, up 3 over 4. It's a positive line going uphill from left to right. Okay. Any questions on those? That's identifying slope and y-intercept. Again, still stuff we've done before last week. Okay. The rearranging the equations is the part that usually trips us up a little bit. Okay. We have to get y by itself first. All right, this one's not on your graph, or not on your sheet, but I just want to write the equation in this line. This is good review for the quiz. Okay, I do the same thing. I'm looking at this line. Okay, I want to know what's the equation in slope-intercept form. So that means I need 2 things. I need the slope, and I need the y-intercept. I can get both of those things by looking at this line. What's the y-intercept of this graph? Yeah, -2. It crosses the y-axis, -2. That goes in for B, right? Okay. Then all I need is the slope of this line, to have it written in slope-intercept form. So it gives me 2 points I can look at here. I just could pick any 2 points on the graph to do rise over run. So let's say I'm going from this point to this point. I need to go up 1, 2, 3, and to the right 1, 2. Remember, the numerator is how much we go up or down. The denominator is how much we go left or right. There's that equation in slope-intercept form. All I need is 2 things, slope, y-intercept. All right, here, again, this one's not on your sheet. Y equals mx plus b. I need 2 things. I need the slope. I need the y-intercept. What's the y-intercept here? 1, 2, 3. Oh, yeah, that's kind of a big dot. But 1, 2, 3. I'm going to have this y-intercept is at +3. Okay. Now it's a downhill line from left to right, so is the slope going to be positive or negative? It's going to be negative. Okay. Let's say I'm going from this point to this point. I'm going down 1, 2, 3, 4, 5. Since I went down 5, that's negative. And I go to the right 1, 2, 3, 4. I go to the right, that's positive. There's my equation. Okay. Y equals -5/4 x plus 3. Okay. So these are the next one. Now I have an equation. Okay, this is the kind of new stuff. I have an equation and I want to know, is this point on this line? One way you could do it is you could graph that equation and then you go find this point and see if it's on the line. That would take forever if we had to do that for everyone. Okay. What we can do though is we can plug this point into this equation and see if we get something that's true. If we get something that's true, it's on that line. If we get something that's false or that's not true, it's not on that line. Okay? What I mean by that is, here's my equation. Okay? Is this the x-coordinate or the y-coordinate? That's the x-coordinate. X-coordinate always comes first. This is the y-coordinate. So I'm going to plug this in for x. I'm going to plug this in for y and see what happens when I simplify that problem. Okay? So I'm going to plug in -5 for y. And I'm going to plug in +3 for x. Remember when I plug it in parentheses. Okay. I'm going to simplify this right-hand side. I do the multiplication before I do the addition. -3 times 3, -9. And then I can do that addition. -9 plus 4 is -5. I get negative 5 equals negative 5. Is that true? Yes. So that means, yes, this point lies on that graph. Because I got something that was true. If I would have got like negative 5 equals 10, okay, I know that point's not a part of that equation. It wouldn't work. Okay? It's not part of that equation. So I want you to look at the next one underneath that. Now that's not in slope-intercept form, right? If you need to check if a point is on this graph, you don't need to put it in slope-intercept form. You can just plug it in and see if you get something that's true. If I asked you what the slope of this was, you would want to put it in slope-intercept form. But if I just ask, is this point on this graph? Plug it in, see if you get something that's true. If you do, okay, it's on the graph. If you don't, it's not on the graph. So I'll give you a couple minutes to try this one. This one's a tad different. I want you to tell me, is 8, 4 on that, the line of that graph? So hopefully what you've started to do is, this is the x-coordinate, right? 8's the x-coordinate. 4 is the y-coordinate. I'm going to plug that in for x and y and see if I get something that's true. So plug in 3 times 4, because that's the y-coordinate, equals 2 times 8 minus 1. Well, that's 12. That's 16. 16 minus 1 is 15. Is that true? Does 12 equal 15? Nope. So the answer would be no. This point is not part of this equation, and that point is not on that line, because I got something that wasn't true. Right? I plugged in 4 for y. I plugged in 8 for x. Simplified it. I got 12 equals 15. I know that's not true. So the answer to that one is no. So that's how we check if we have a point. Is it on that equation? We just plug it in and see. Any questions with that so far? Another good review question for the quiz. If I want to graph this equation, this one's not on your sheet either. If I want to graph this equation, why can't I graph it as it sits right now? The y is not by itself, right? I need to get it in slope-intercept form, isolate the y, get the y by itself. Okay? So just pretend this was like a 2y plus 40. If it was that case and you want to get y by itself, you would subtract 40 from both sides, then divide by 2. I do the same thing if it's 4x. Okay? I want to move that 4x to the other side first, so I'll subtract 4x from both sides. I get 2y, that goes away, equals 0 minus 4x is just going to be minus 4x. Okay, I don't have to write the 0 there. Finally, I need to divide both sides by 2 to get the y by itself. Divide this side by 2, divide this side by 2. That becomes 1y. Negative 4 divided by 2, negative 2x. Now it's in slope-intercept form. But what's my y-intercept here? 0, right? My y-intercept is 0. I don't have a y-intercept, so I'm going to put a point at 0 on the y-axis. And my slope is the number in front of the x, negative 2. Remember, if it doesn't have a denominator, you can put a denominator of 1. That means I need to go down 2. The top number tells me how much I go up or down. The bottom number tells me how much I go left or right. Down 2, the right 1. Down 2, the right 1. Do that a few times. There's my points. Draw my line, put arrows on the end. There's that equation graphed. So if I ask you, for example, is the point 1, 2 on this line? Well, first you could just look. Is the point 1, 2 on this line? 1, 2, it is, right? Or I could plug it in, either up here or up here. If I plugged in 1 for x and 2 for y, okay. Or sorry, 1 negative 2. 1 2 is up here. 1 negative 2. Okay, if I plugged in 1 for x and negative 2 for y, that becomes negative 4 plus 4 is 0. That works. Same thing if I plugged it in here. Okay. So that's how we graph. We need to put it in slope-intercept form. The last thing, this is the kind of new part, okay, is if we write an equation when we're only given 2 points. Earlier you guys were given, if I said the slope is this and the y-intercept's this, put it in slope-intercept form. You plugged in the slope, you plugged in the y-intercept, that was it. Okay. Now I'm just going to give you 2 points and have you tell me the slope-intercept form. Okay, there's 3 steps to doing this, and I wrote these on the sheet there. Okay, step 1 is you need to find a slope between those 2 points. You showed me you could do that in the first 2 problems. If you have 2 points, you can find the slope between them by using that formula, slope formula. Right? Remember, you always need 2 things. You always need the slope and you need the y-intercept. Well, in step 1, you found the slope. In step 2, you find the y-intercept. How you do that, okay, is you're going to plug in a y-coordinate, the slope, and the x coordinate into the equation, and you're going to solve it for b. You're going to find out what b equals. Okay, we're going to do some practice with that. In step 3, now that you have the slope and you have the y-intercept, you just plug them in. So for example, this is the first one on your sheet. I want you to write this equation in slope-intercept form. Again, just a reminder, this is slope-intercept form. Y equals mx plus b. You need two things to write this in slope-intercept form. You need the slope, and you need the y-intercept, which is b. So you need to get these two things from this pieces of information. Once you have those two things, you're done. Okay. Well, we know how to find the slope between these 2 points, right? That's the first thing we need is the slope. So go ahead and find the slope between these 2 points on that sheet. I want you to find the slope between these 2 points first. So if you label that the first x, the first y, the second x, the second y, you take 7 minus 5 divided by 4 minus 3, that's 2 over 1, which is 2. So you get a slope of 2. This problem's half done, right? I need two things. I need the slope, I need the y-intercept. I just found the slope. So the only other thing I need to find here is the y-intercept to be able to write the equation. Now to do that, step 2 is you plug in a y-coordinate, you plug in a slope, and you plug in an x-coordinate, and you're going to solve for b. It doesn't matter which of these coordinates you pick for x and y. But if you pick this for x, you need to pick this for y. Or if you pick this for x, you need to pick this for y. You have to pick them in pairs, or the ordered pairs they're in. Okay? Let's say we're going to use the first set. I'm going to plug 3 in for what? X or y? Is it the x-coordinate or is it the y-coordinate? It's the x-coordinate. That's the y-coordinate, right? So in this equation, y equals mx plus b, I'm going to plug in 5 there because that's the y-coordinate. I'm going to plug in 2 there because that's the slope. And I'm going to plug in 3 there because that's the x-coordinate. That means the only thing left is b. And I can solve this equation for b. So let's do that. I have 5 equals 2 times 3 plus b. I plugged in the y, the m, and the x. I need to solve this equation for b. Now it's just solving an algebra problem. 2 times 3 is 6. I need to move that 6 to the other side so that I can get b by itself. It's a positive 6, so I'll subtract it. I'm left with b equals negative 1 because 5 minus 6 is negative 1. Remember at the start of this problem I said you needed two things. You needed the slope and you needed the y-intercept. I have the slope, I have the y-intercept, now I can write the equation. I just plug in the slope and the y-intercept. So it's y equals 2x minus 1 or plus a negative 1. That's the equation of this line. Yes?
Since the y or the y1,
Yep.
since that's a 5, you just do it so you can why can't you do 5 minus 7?
On this point?
Yeah.
If you could, if you did 5 minus 7, you'd get negative 2 here. Then you'd do 3 minus 4, which you'd get negative 1. So negative 2 over negative 1 would be positive 2 still. Right, you could do it that way. You're right. I just picked that way to do it. Yep, good question. Okay. And again, once you need two things in all these problems. You need the slope, the y-intercept. We know how to find the slope. We use slope formula. To find the y-intercept, we just pick a y, m, once we found it, and an x, and solve for b. Okay, that's the only new thing we're doing today. So go ahead and try this one yourself. You need to find a slope, and you need to find the y-intercept. You need those two things. You need to find them based on this information. Now we know how to find the slope, so go ahead and do that. And then I want you to find the b coordinate by plugging stuff in. So I'll give you a couple minutes to try that. You need two things, the slope and the y-intercept. So hopefully first you found the slope to be that. You took the second y minus the first y divided by the second x minus the first x, and you got a slope of negative 3. Even if you pick this to be the second x, the second y, and this the first x and the first y, you still get a negative 3 slope. So half the problem's done. Again, you need two things. You need the slope, and you need the y-intercept. Now we need to find the y-intercept. And remember, we do that by going back to the slope formula and we're going to plug in a y coordinate, an m, and an x, and solve for b. It doesn't matter which y coordinate you plug in, but if you plug in this y coordinate, you need to plug in this x coordinate. If you plug in this y coordinate, you need to plug in this x coordinate. Doesn't matter which one you pick, you'll get the same answer either way. Okay? Let's say we picked the first set last time. I'm going to pick these two, 8 and 7. If you pick the other ones, that's fine. I'm going to plug in 8 for the x value, and I'm going to plug in 7 for the y value, because it's the x and the y coordinate. So I get 7 equals m. Again, m was -3. X was 8 plus b. B is what I'm trying to find. Because all I need to do is solve this equation for b now, and I'm done. Yeah. So, -3 times 8 is -24. Last, I need to move that -24 to the other side of the equal sign. So how do I get it to equal that 0 on that side so that I can move it to the other? Add or subtract it? Add it, because it's a -24. So add 24 to this side becomes 0. Add 24 to this side. That is 31. All I'm left with is b. So now I have my slope, and now I have my y-intercept. Now I can write the equation. Okay. So it's y equals -3x plus, because it's positive, 31. There is the equation. Okay. And so these problems, you just need to find two things. You need to find the slope and the y-intercept. Once you do that, you can write the slope and the y-intercept in the equation. Okay. That's the only new thing we're talking about today. Slope and the y-intercept. Yes?
Does that say 31 equals b?
Yes, 31 equals b, because I'm left with b on the right-hand side. 7 plus 24, I get 31 there. All right, so the very last one we're going to look at. Any other questions on this one before we go to the last one? All right, the very last one, 6 and 1, 2 and 4. I'm going to go ahead and work it out up here. I want you to try it, and anytime you get stuck, look up and see if you check your answer. So go ahead and try this one. I'm guessing this might be the part some of us get stuck on when we're multiplying the fractions. So I have the m, which was -3/4, times, I picked this to be my x value and this to be my y value. You could have picked this one. When you multiply these fractions, remember you multiply numerators together, you multiply denominators together. So you should get like -6/4. Yes, question? I can simplify -6/4. Both of those numbers are divisible by 2. So I'll divide them both by 2. It gives me -3/2 plus b. Again, I'm trying to get b by itself because I want to know what b equals. So I just need to move this -3/2 to the other side. Just like if it was a -3, I would add 3 to both sides. If it's a -3/2, I need to add 3/2 to both sides. Now, you could change this to a decimal. You wouldn't be wrong if you want to change that to a decimal and then add 1.5 to both sides. You could do that. Okay. I'm going to suggest not doing that because when we're talking about slope, we don't want to change it to a decimal, so we should probably leave our y-intercept as a fraction. If you did it, I'm not going to count it wrong or anything, but I would probably leave it as a fraction. Okay. So the last step I need to do here is add 3/2 to both sides. That becomes 0. Add 3/2 to this side. Again, this is the part that might trip us up. We're just adding fractions. 4 plus 3/2 equals b. Remember, I need a common denominator to add fractions. So that means my common denominator here is going to be 2. Means I need to multiply top and bottom here by 2. So that's 8/2, because that's 4, plus 3/2, that's equal to b. Well, 8 over 2 plus 3 over 2 is, add the numerators together, 11. Leave the denominators alone. 11 over 2, so that's B. I'm going to go ahead and leave it in proper.
How'd you get 8 2?
I got 8 over 2 because I multiplied the numerator and denominator here each by 2. That way I could get a common denominator. I had to multiply 1 by 2 to get 2 there. I had to multiply 4 by 2 to get 8 there. Okay. So that's my y-intercept. That's my slope. Now I can write my equation. My equation, I'm going to plug in negative 3/4 for the slope. I'm going to plug in 11 over 2 is the y-intercept. That's as hard as they get because we just had to deal with some fractions there. Okay, that's just adding, subtracting fractions. Otherwise, this process is the same though. Find the slope, find the y-intercept, plug them in. So that's my final equation. So any